This is a question from a test I gave to my Year 12 further mathematicians on calculus. This particular question is asking us to differentiate. And first of all, though, it's just asking us to verify that this point here, 2, 7, is on this curve, which is called C. Then in part B, it asks us to find the equation of the tangent at C in the form y equals mx plus c. And then finally, there's another point Q, which is on C. It so happens that the tangent at Q is perpendicular to the tangent at P, and we're asked to find the x coordinate. So let's see how we get on. First step is verifying that point 2, 7 is on the line, and to do that you just need to substitute the values in. So we've got the equation here, so let's see if that works. Y is 7, so I've replaced y with 7, and x is 2. And if we substitute those in, what we're hoping to find is that 7 equals 7. And you should find that it does, surprisingly enough. 7 equals 7, so P lies on C. 1 mark in the bag. Part B involves a bit more. We've got to find the equation of the tangent, and if we're going to do that, we're going to have to find the gradient. M is the gradient, and to find the gradient you need to differentiate. And if we differentiate our curve, we end up with 3x squared. Power comes down and bring the power down by 1. Do it again, times by the power comes down by 1, we're left with 1, and the constant 9 is differentiated away. So let's have a look at what the gradient will be at x equals 2, so essentially at P, and the gradient will be whatever we get when we put 2 into our gradient function, or our derivative. 3 times 2 squared minus 4 times 2 minus 1, and that gives us 12 minus 8 minus 1, which is 3. So far in our equation, y equals 3x plus c. So if we use 0.27 again, 7 will be equal to 3 times 2 plus c. So I've put the point into the equation I've got so far, and that tells me that c equals 1, which means we've got y equals 3x plus 1 as the equation of our tangent. Moving on to part C, the question explains that at C the tangent is perpendicular to the one at P, and perpendicular to this in fact. So the perpendicular gradient is the negative reciprocal, meaning it's negative, and instead of being 3, it's 1 over 3. Now if that's a gradient at that point, and we know the gradient function for the whole line, which is our derivative, we can use that to create an equation, and we can find out the x coordinate that way. Rearranging this one, if we add a third onto both sides, we end up with this times everything by 3, just to make it a bit more convenient. And now to work out x, we're going to need to substitute it into the quadratic equation. I'm running out of time on this particular one, so I'm going to make an extra video where I do that, and we'll pick up from here. Sub into quad formula. See you in a minute or two on the next video.